Hello everyone, welcome back to Smart Edits YouTube channel. Myself, Jayan Mohan Reddy. Today we are going to discuss first three problems of weekly contest 407 from LeetCode. Okay, so let's quickly start with the first problem. And this the problem statement for the first problem is you're given a two positive integers n and k. Okay, so you're given two positive integers n and k. Okay, now you can choose any bit in the binary representation of n that is equals to 1 and changes to 0. Return the number of changes needed to make n equal to k. If it is impossible, return also. So simply what is the problem statement? So you can choose any bit in the binary representation of n. Okay, you can pick n and you can choose any bit in the binary representation of n. Then uh, that should be set bit that you can change to 0. Okay, and ultimately your aim should be you should make n equals to k. So if it is not possible to convert n to k, we should return minus 1. So to understand better, let's go through the examples. So first example, n is 13 and k is 4. And what is binary representation of n? It will be nothing but 1, 1, 0, 1. Okay. So it will be 8, 4, 2 and 1. 8 plus 4 is 12. 12 plus 1 is 13. Okay. Similarly for 4, 0, 1, 0, 0. So simply how many set bits you need to make it unset so that 13 will become 4? Can I simply say if I make this to 0 and this to 0, this will be converted to 4. Yes, sir. So how many bits? 2 bits. Now let's move forward. Let's go to another example. And what is the other example? 21, 21. Can I simply say if both the numbers are equal? Already, there is nothing to do. Yes or no? Simply you can return 0. And let's go to third example. Let's go to third example. So what is the third example? Simply n is 14 and k is 13. What is binary representation of n? It will be nothing but 1 1 0 1. Sorry, 1 0. Yes or no? And what is k? K is nothing but 1 1 0. Now you can convert this bit to 0, this bit to 0. But what about this bit? Sorry, you can also, sorry, my bad. You can simply convert this bit to 0. So these three bits are same. But what about the last bit? I mean, least significant bit. What about it? Can you convert 0 to 1? No, we can only convert 1 to 0. So simply can I say uh, it is impossible to convert into k? Yes or no? So what we should return? We should simply return minus. Now, I assume you guys are clear with the problem statement. Now let's see how we can solve this problem. So simply what should be the condition? How can you say whether you can solve this or not? Like firstly, can you convert into k? Firstly, you should check. If you cannot convert into k, you can simply return minus. So firstly, let's do that. So how can you check that? Every time, let's say these are the bits. This is the 0th bit, this is the first bit, this is the second bit, and this is the third bit. Okay. Now, simply what you can do, similarly here as well. This is 14 and k is 13. And here n is 13 and k is 4. Here also 0th bit, first bit, second bit, and third bit. So simply what you can do every time, let's take the first example. Every time you can compare k and n. Okay. So if particular bit is set in n and not set in k, so simply you can convert this to 0. Yes, sir. So you can maintain some variable count. Initially it will be 0. So you can check whether we will see how we can check a particular bit is set or not. As of now, this is our approach. Simply we'll check 0th bit is set uh, in 13 and 4. If it is set in 13 and if it is in unset in 4, simply you'll increment the count. Okay, again you move forward. If the both the bits are unset or set, you don't do anything. You'll simply move forward. And again, if a bit is set in n and unset in 4, again you increment the count. Okay, so finally you'll get your answer. In case of 14, let's see. When you're at 0th bit, n is having unset, but n is having unset, but k is having it set. But you cannot convert 0 to 1 in n. Simply when you came across a scenario where particular bit in n is unset and particular bit in k is set, you can simply return minus. That's all. So this is how you can solve it. So simply now what is the thing? You should whether particular bit is set or not. So for that, how you can check a particular bit is set or not? So let me take a number. Let's take 13. 1101. And this is 0th bit, this is first bit, this is second bit, and this is third bit. Now I want to check whether third bit is set or not. So how I can do it? Are you guys aware of right shift operator? Right shift and left shift. So simply let's say if you do 13 left shift by 1, then what happens? Simply if this is a binary representation of 13, when you do 13 left shift of 1, every bit will be shifted towards left side by 1. Okay, so this is what happens when you left shift 13 by 1. Similarly, if you right shift 13 by 1, then what happens? This is a binary representation. So these bits will move forward. Okay. Now, simply if you right shift 13 by 3 times, then what happens? So the bit will be shifted by 3 times. Okay. So simply what happens is it will be something like this. So this will come out of this will come out of this will come out of this. Finally, this bit will be replaced here. These bit will be seen and rest of the bits will be gone. Okay. And other bits will be filled with 0. So this is what happens when you shift your, okay, when you right shift a particular number by k times. Okay. So simply if I am, let's say I equals to 3, I want to check whether ith bit is set out in the given number. Let's say n equals to 13, and this is the binary representation of 13. So simply I want to check whether third bit is set out. So if I do n right shift by I, what happens? This will become something like this: 0, 0, 0, and 3 will come here. That will be nothing but 1. If you simply I is 2 and right shift by 2, then what happens? This will be 1. Okay. Simply these two bits will come to LS. Okay. Now, once you have this, okay, this is the second bit for 13. Now you want to check whether it is set up. How you can check? Let's say if I do AND operation with 1. If I do AND operation with 1, what should be the output? This should be the output. And if I do AND operation with 1 and if this bit is unset, then what should be my output? It should be simply 0. Yes or no? Because rest of the bits will be anyway 0. So all the bits will be 0. And only this will be the deciding factor. LSB will be the deciding factor. And if both the bits are set, then it will be 1. If the this bit is 0, this will become 0. Okay. So simply how you can check whether a bit is set or not? Can I simply write something like this? N right shift by I. Okay. And if I do AND operation with 1, and if it is equals to 1, then it is set. If it is not equals to 1, if it is equals to 0, then it is not set. As simple as. Okay. Now you know how to check the number of bits. Now, can you tell me how many bits will be there in a number. So the given value is 10 power 6. Your n and k will range till 10 power 6. And for 10 power 9, your till the integer range will be 10 power 9 and you will be having 32 bits in. Okay. For 10 power 6, you will be having around 20 bits. So we'll do one thing. We can simply traverse till 30 times. Okay. And we can check for every bit. Okay. So simply, what will be our code? Every time you will be traversing for I equals to 0 to 30 times. And you can do either this, or you can simply pick n and k, and you can find the number of set bits, number of longest set bits. In this case, it is 4, and in this case, it will be 4. Okay. If you are having some number like this, so in this scenario, it is 6. So instead of traversing for I equals to 0 to 30 times, you can simply traverse from 6 times. That will also work. But since it is a not big difference, I'm taking it as set. Okay. So for every bit, what I will be doing, firstly, I should check a particular bit in K is set or not. Okay. So there are two things. If the bit, if a particular bit in N and K is equal, we'll be doing nothing. But if a particular bit is set in K and not set in L, then we will return -1 because it will be impossible. So what is the first condition? If let's say I write some function for check bit and I will pass K comma I. That means ith bit, we are checking whether ith bit is set in K or if it is true. If ith bit is set in K and set in N, simply what you can do, you can return -1. Okay. If this is not the case, if it is vice versa, like let's say if a particular bit is not set in K and if a particular bit is set in N, you can simply return, sorry, you will not be returning anything. So when this is the scenario, we will maintain some count variable as we discussed and you simply increment the count. By the end, you will return count. Okay. Yeah. That's it. Now let's move to coding part. Let's quickly code it up. Okay. Let's quickly write code for first order. So firstly, what we thought initially we will be having some count variable const equals to 0. So every time what we'll be doing, we'll be traversing for I equals to 0, I less than 30 till 30 bits, I plus plus. Okay. So you can do either 30 or you can simply, you know, find out the length of the longest like binary. You can simply find the most significant bit of n and most significant bit of k. Based on that, you can take the length. But for simplicity, I'm taking till that. Okay. Now, simply we will be having two conditions. If a particular bit is set or unset in both the numbers, that doesn't make any sense. We should be taking care of two scenarios. One, if let's say I had this function check bit. Okay. In this check bit, I will pass a number and a particular bit to check whether it is set or not. If it is set, okay. So let's say number is set in K and the particular bit is not set in N. Then what we should be doing? we should return -1. Else if, what is the other condition? Simply vice versa. If a particular bit is not set in k and it is set in n, so simply what we will be doing, we will simply increment the count. And finally, we should return count. So keeping one test case in mind, that is nothing but if n equals to k, we don't need to do all these things. We can simply skip that. So I simply written 0, and we should implement function, check bit function. So that function is nothing but boolean of check bit. Okay. So this check bit will take a number and a particular bit. Okay. It will take a number and bit, and it will simply check whether the particular bit is set or not. And how we can check that? If number is right shifted by bit times, okay, and if we simply do and of 1, and if this is equals to 1, then we simply return true or else we return false. Let's run the code. Let's submit it. Okay. Uh, let's move to second problem. Let's go through problem statement of second problem. This is a given problem statement. So you are given Alice and Bob are playing a game on a string. Okay. And you are given a string, yes. They're playing a game and you are given input is a string. Alice and Bob will take turns playing the following game where Alice starts first. Okay. Alice and Bob are playing. Alice will be taking the first turn, and this is a game. On Alice's turn, she has to remove any non-empty substring from S that contains an odd number of vowels. So Alice should remove odd number of vowels substring. Okay, it should be non-empty. And similarly, Bob, on Bob's turn, he has to remove any non-empty substring from S that contains an even number of vowels. Okay, Bob should remove a non-empty substring which is having even number of vowels. The first player who cannot make a move on their turn loses the game. We assume that both Alice and Bob play optimal. Okay. So what is the winning condition? Simply the first player who cannot make a move. Okay. Let's say if there are zero, simply zero vowels. If this is a given string, if this is a given string, Alice cannot make any move. Why? Because there is at least you know if there the number of vowels are zero. So they cannot like Alice cannot pick a substring having odd number of vowels. Okay, for picking odd number of vowels, Alice should have at least one vowel in it. Okay, so Alice will be lost. Similarly, if let's say if it is having three, simply Alice can pick. Let's say if the given string is something like this: A E X Y I. So the number of vowels are three A E I. Simply if Alice pick entire string, what happens? The number of vowels will be zero and Bob cannot pick any. So LS is so simply what you should return is return true if LS wins the game and false otherwise. So the English vowels are A E I O U as you know. And simply other point here we should keep it in mind is they are playing optimum. That means LS will pick in such a way that definitely he will make sure Bob will lose the game. Okay. And similarly, Bob will make a move such that it will make allies losing. So both are playing optimal. That's the point. Now, let's see a few examples to understand better. The given string is lead code. So given string is Simply, can you tell me number of ovals? Four. Okay. So who should play first? Simply LS. And how many LS can pick? Firstly, LS should pick odd number of ovals. Okay. So simply out of four, what are the choices for LS? He can LS can pick either one or two. So if LS pick one, then what happens? This will become three. Then in next game, like Bob can pick two, and the one will be left. Again, allies will win. Yes, sir. Similarly, if allies pick three directly, so what happens? The number of ovals will be one, and Bob cannot pick one because Bob should pick even number of ovals. So definitely allies will. Okay. So we can simply return true. Similarly, BBCD, how many ovals are there? How many ovals are there? Zero. So allies cannot make any. So as of now, keep this string aside. Simply let's take the number of vowels and see for each number of vowels who are going to win. So if there are zero vowels and one, two, three, four, five, six. Let's see for first six. Let's take Alice and Bob who will win. Simply, if there are zero vowels, Alice should make the first move and Alice cannot make any move. So simply Bob will win and Alice will lose. And if there are one vowel, if there is one vowel, Alice will be having the first choice, and Alice will pick that one vowel. So Alice will win, and Bob will win. Similarly, if it is having two vowels, Alice can pick one. Out of two, Alice can pick one, and out of this one, Bob cannot pick anything because Bob should pick even number of vowels. So definitely Alice will win. And same for three, Alice can simply pick three votes. So every time when it is odd, can I simply say Alice can pick all the odd or like entire string and Alice will be win. And similarly, if it is even, let's say for four, Alice can pick three and he can make it one. So definitely Alice will also win. So can I simply say apart from zero, whatever the number it is, Alice will be winning. And apart from zero, whatever the number it is, Bob will be losing. Yes, sir. So simply what will be our solution? We should be counting the number of vowels. Once we got the vowels, if the number of vowels are zero, that means Bob wins. We should return false. We should return false. Apart from zero, if the number of vowels, whatever the number it is, simply we should return true because ls will. Okay. So this is the approach. Let's quickly code it. So simply, what is the code for second problem? So we should count the number of vowels. So let's take a variable and let's traverse through the string. And every time we can check whether the character is vowel or not. Sorry, A E I O U. Simply you can increment the count of vowels variable. Then finally, if the number of vowels are zero, that means Bob will win. So you'll simply return false. Else you'll return true. Let's run the code. Let's submit it. Yeah, that's it. Okay, let's start with the third problem. So let's go through problem statement. So you are given a binary string. Binary string is nothing but string which is having only zeros and ones. So uh, you can perform the following operations on the string any number of times. Okay, you can perform the following operation on the string any number of times. So let's see what are these operations. So firstly, you can choose any index I from the string where I plus 1 should be less than s dot 1. So simply when you are picking I, when you are picking I, you should take care that I plus 1 is less than s dot length. That is nothing but I plus 1. When you are choosing I plus 1 should be within the given range. Okay. And such that s of I. So firstly, when you are picking I, this should be the condition. I plus 1 should be less than s dot length. This should be the first condition. And what about second condition? Simply s of I should be 1 and s of I plus 1 should be 0. Okay. Now move the character s of I. Move the character s of I to right until it reaches the end of the string or another one. For example, they are giving a string 0, 1, 0, 0, 1, 0. So simply if you are moving this string, sorry, this particular character, if you pick this as I plus 1 is less than s dot length and s of I is 1 and s of I plus 1 is 0. Now you can perform second operation. It is nothing but you can move this one until end or it come across first one. So that is nothing but this one will come here and this will be the resultant. So this is one operation. This is one operation. No matter how many zeros are there in between, it will be considered as one operation. So simply if you want to move this one, then you can move till end. So this will be another operation. Okay. So initially operations equals to 1. Now it is operation. Again, can you move anything? Yes, 1. Yes, sir. So simply you will move that 1 and that will be third operation. So total how many maximum possible operations are we getting? 3. Yes, sir. If you simply do these operations in this way instead of doing it that way, if you are doing it this way. So firstly you are moving this 1. So that will be nothing but 1, 0, 0, 0, 1. So this will be first operation. And now you can move this one. So you are getting two operations. So in this scenario, you are getting three operations. And in this scenario, you are getting two operations. So what are the maximum number of operations that you can get? Simply three. Yes, sir. So this should be your output. And let's see examples for understanding better. Let's take the first example. Or let's first take the second example. Okay. So given string is 0, 0, 1, 1, 1. So simply, can you move any of the one? Yes, sir. This one you cannot move, this one you cannot move, and this one you cannot. So how many operations you can perform? Zero. You cannot perform any operation. Okay. Keep this in mind. Return the maximum number of operations. So you cannot perform any operation. Let's take the first example. Let me move this thing towards right. I hope everyone is clear till now. Let's take example. So given string is 1, 0, 0, 1, 1, 0. Okay. Can you move this one? No, you can move this one. But in the previous scenario, if you observe, when we are moving the ones that are towards right side, we are getting less number of operations. And when you are moving the ones which are at the beginning, we are getting more operations. So let's start from here. So let's simply do something like firstly, you can move this one. So that will be nothing but 0, 0, 1, 1, 1, 0, 1. So this is one operation. And now what you can do, you can move this one 0, 0, 1, 1, 0, 1, 1. So this will be second operation. Again 0, 1, 0, 1, 1, 1. Third operation 0, 0, 0, 1, 1, 1, 1. Fourth operation. Okay. So at max you can get four operations. So how we can solve this? So first thing, what can be brute force solution? Can you think of? Pause for a second. Think for brute force solution. And what can be brute force solution? Every time you can pick a string and you can keep modifying this string. Yes, sir. You can keep modifying this string uh, until you can you cannot further make any. That way you can get the operations. So that will be brute force solution. And what will be the time complexity for that? In the worst case scenario, how many operations can you get? Can I simply say you can get n operations in the worst case scenario? And every time for making this move, you traverse for n time. So can I say it will be simply n into n. And now if you see the constraints, your string length is 10 power 5. So if you are trying to get solution for 10 power 5 to 10 power 5, can I simply say it will be 10 power 10 and it will not be executed in the given time. So what we get? What can be the expected time complexity for 10 power 5? It can be either n log n, this will work, or n. For n log n, we cannot sort this. So we should be think of a solution in n. Now, let me give you a small idea. So simply, if you consider only this string, okay? If you consider only this string, sorry, my bad. If you only consider this character, first character, or like, let me write it, zeroth index character. Let's see how many operations you are getting because of this. Firstly, you are getting one operation when you are moving it to second index, okay, from 0 to 2. Again, when from 2 to when you are moving to 3, you are getting another operation. Yes, sir. Now, can I simply say why uh, you are getting first operation because of the zeros lying in between, and why you are getting second operation? Can I simply say because you moved these two ones to right side? Yes, sir. So can I simply say whatever operations happening after it, it will be affecting the initial. Now, let me modify this example. Okay, you will understand it better now. So simply let's take 100 and 1. Instead of 1, 1, I will take 0. Firstly, let me take the same example. So initially, what is the number of operations you can get because of this? Can you tell me? Can I simply say 0? Okay. Or else can I simply say, if you see the second example, that is nothing but 000 and 1, 1 or 4 ones. So simply, what are the operations that you can get from this one? Can I simply say 0? What about this? What about this? What about this? So no matter how many ones are present at the end of the string, will it make any sense? No. So simply, I will start from the first 0 that I am coming at. Okay. I will skip all the ones. I will come to first 0. Now, with 0, we cannot get any contributions. So I'll move to this one. So at this one, how many contributions, like how many operations can we get? Can I simply say this is the first one from the backside? Okay. So how many times I can, in the worst case scenario, even if I'm having 0 here, I can move till end. Yes or no? So can I simply say, can I simply say this will contribute to one operation? Yes sir. Now, again, what about this? What about this one? Will it make any contributions? Simply when this one move to end or to the next move. Okay. If this is the scenario, it will also contribute one more operation. Like it depends on this particular operation. How many operations these one is giving? Same number of operations this one also will give. Can I say something like that? Why? Because there are no zeros in between them. And how many times this one will move? That many times this one will also move. Okay. So can I simply say the number of operations this one is contributing? The same number of operations this one also contribute. So can I simply say I'm getting two operations till now, and this is contributing. Let's say the previous, I name it as previous. Like what is the previous one contribution? The previous one contribution is one when it is here. And when you see there are no zeros between the previous one, so I'll maintain some index. What is the previous one? That is nothing but 4. And if you see the current index, that is 3. If there are no zeros, that means previous index minus current index, if it is 1, that means there are no zeros between these two ends. And there will be no increase in contributions because of this one, because there are no middle zeros. So it will also make same number of contributions that the previous one is made. Can I say something like that? So what happens? Previously answer is 1 and previous number of contributions are 1. So these also will contribute for 1. My answer will become 2. I will move forward, like I will move backward and I will come across this index. When I'm here, the previous the previous one having its index is 3. Okay, the previous one is at index 3 and the previous contribution done by that one is also 1. Now, if you see index minus 1, like index minus previous index minus current index is greater than 1. That means there are few zeros in between those two ones. So can I simply say along with the previous contributions, it will also make another contribution? Yes, sir. So I can simply make the contributions will be increased because there are few zeros in between. And I'll simply add that to answer. I'll get maths. Okay. So for understanding better, I will take an example considering all these scenarios. Okay. So let me write like this: 100 and 10 11 and 00 11. Okay. So firstly, let's cover this case, the number of contributions made by the last index. And let's take this, take the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. So what are the contributions by this one? Can I simply say I can skip all these ones because they make no sense? So I'll directly come to this index. Now, at this point, I will maintain three variables. One is answer, that is nothing but 0, and previous and index. So initially, I will initialize my index to -1, and initially my previous will also be 0 because the contributions made by this ones will be 0 and answer also 0. Now, when I'm at 8th index, it is not, it is 0, it is not 1. So I'll move backward. Okay. So I'll take my current index as I. So my current index is 7. It will make no sense. My current index is 6. So I will check with the previous index. Okay, and previous index is, if previous index is -1, that means this is the first one that is going to contribute for the operations. Okay, so simply what I will do is I'll make it to I'll update my previous index to 6, and I will make the previous to 1, and I will add the previous operations to answer. Okay, now simply I will move forward, like I will move backward. Now my index is nothing but 5. Okay. Mm, let me make a small modification. Let's have it 1 and 6. Okay. So simply, what are the my current I will be at 5. So it makes no sense. My current I will be 4. Okay. So when my current I is 4 and index is 6, previous index is 6, the difference is 2. That means there are few zeros in between these two indexes. So simply what I will do is along with the previous contributions made by that one, this will also make another extra contribution. Okay. So that I will add to my answer. So my answer will become 3. Okay. Now, again, I will update my index to 4. I keep moving my I. So my I will be. Now, I will take the difference of previous index and current index. So it will be nothing but 4 minus 3, that is 1. So now the current one, it won't contribute anything extra. Why? Because there are no zeros in between. So simply what I will do is, I don't make any change for previous. I simply add the number of contributions this particular one can make. So how many contributions it can make? 2. So I'll add that to answer. It will be 5. Okay. Again, I simply keep traversing. I will update my index to 3 and I keep traversing my I until I found another one. So I found it 0 then. Now what I will be doing? I will take the difference and the difference is greater than you. That means This will also make extra contribution to the previous contribution. So finally, we'll add that previous to answer. This will be 8. So finally, my answer will be 8. Okay. I hope everyone is clear with the approach. I can understand like it is a bit confusing and it's kind of chaotic. It's tough, but try to process it and try to like try to drive so you'll understand better. Okay, take this example. Pause for a minute. Take this example. Once see in this approach, and then try to apply this approach so that you will understand how exactly we are getting the task. Okay, so let's quickly write code for this. Let's move for coding part. Okay, so let's quickly write code for this. So firstly, if you look at the constraints, our string length can be 1. So if it is 1, it makes no sense. Even it is 0 or 1, the number of, you know, our answer will be 1. Sorry, our answer will be 0. So let's handle that case first. So simply when you are writing code, keep constraints in mind and see if there are any corner cases and handle them in first place. Now let's take previous index. I'm naming it as IDX. I will initialize to -1 and I will take answer and I will take previous. Okay. These are the variables that we consider. And apart from that, we shouldn't be starting from the last index. Instead of that, we can skip all the ones and we can start from the first 0. Okay. So for that, I'm going to take a variable k and I'll initialize that to -1 and I'll simply traverse this k and I'll keep decrementing. Okay. Once I'm done, I will start from that particular k I equals to k. I will skip all the k, all the ones that are present that are present at the last or end of the string. I'll skip them and I'll start from the first 0 at the end of the string. Okay. And I will traverse till I greater than or equals to 0 and I keep decrementing. Now, in this array, firstly we should do something only when s of I equals to like 1. Then only we should be doing any kind of operation. So the particular current index is 1. Then what I should be doing? I should take, uh, firstly, I should check whether it is the first index. Okay, simply what I'll be doing, previous will become 1 and I will add that previous to answer. So simply we can do this and I should update index to I. These are three things you should be doing. Else, like if it's not the first occurrence of 1, then what we should be doing? We should check whether previous index minus I is greater than 0 or not. Like if it is greater than 1 or not, that means if there are any zeros present between previous index and current index. If there are any zeros present, simply we should increment previous. And finally, we should add to answer to the previous and index I should update. So simply if you observe, we are doing this for 2 times. So what we can do is we can have control X, control. So no matter, even if it is if or else condition, this will anyway get executed. And here, if you simply see, can we optimize this further? Like, can we simplify this code? If you observe, I can start my previous with 1 and simply if index not equals to -1, okay? If index not equals to -1 and this condition as well. If it satisfies these two conditions, Since I'm already incrementing previous, I should take care of previous plus plus. That's it. You can simply remove this else condition. Okay. If index is -1, then we don't increment previous. Okay. And moving further, if index minus I greater than 1, then only we'll increment. Okay. Now let's move forward. Finally, from this for loop, we can return our answer. Should be code. Let's suppose. Okay. Also, if you observe, we are beating 100% of users. Now, uh, we are done for the day. And if you like this content, please consider liking the video and please share with your friends. And please subscribe to the Smart Intelligence YouTube channel for getting more such content. Thank you.